Hey guys, welcome back. So, we're gonna continue with Advent of Code Day 1. This time we're gonna solve Challenge 2. So, let's get started by reading the description. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read the most of the chief's handwriting, but in the commotion you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that the number appears in the right list. Here are the same example lists again. So guys, as you can see, for this challenge, all we need to do is iterate through the left list, and for each item in that left list, while we're iterating, we count the number of times it exists within the right list. So guys, let's get to the solution. So from the previous challenge, guys, I migrated the list implementation that we implemented in the last challenge so that we can use it in any other upcoming challenges we have. So I'm gonna create a directory for the challenge number 2. Let's change our directory into that. Alright, so I'm gonna copy the example list again. Vim example list example.txt. I'm gonna copy the puzzle input as well. So puzzle.txt. And I'm gonna create a file, guys, called solve.c. So let's create our C file, guys. So we're gonna include the standard input output library, and we're gonna include our list library because we're gonna need to have a data structure to store each numbers in. So we're gonna include the list library that we wrote in the last video. And we're gonna read from the example.txt file, guys. So we're gonna create a file pointer to open up that file. Open example.txt in read mode. And then we're gonna have two variables. We're gonna create some variables. So we're gonna have one to store the left value for the left list and one call the right value to store the right value of the right list. And we're going to create another variable called, they said they wanted the similarity score, so similarity score, set that to 0. And we're going to parse the example.txt file. So we're gonna using the fscanf function. We're gonna read the left value, which is an integer, store it in those pointers. Now guys, we're gonna need to have a user data structure. So list underscore t left list, let's initialize that to 0, right list, initialize that to 0. We're gonna call list underscore destroy before we exit the program. This way we don't have any memory leaks. And each time we're parsing the file, also, meanwhile, we need to check the return value of fscanf. Meanwhile, we're parsing the file. So as long as it is not equal to EOF, which is end of file, then we're gonna call list underscore append left list left value, list append right list right value. We're gonna print out both lists to ensure that everything is fine and we haven't made any mistakes in our code. Alright, now guys, let's compile our solve.c. Alright, and everything has compiled successfully. So guys, let's think about how we could solve this problem. So we know that we need to count each time we're iterating through the left list. We need to count the number of times each element exists in the right list and multiply it by that number of times. Now we could use 2 for loops for this, but that will be kinda too slow. So instead, guys, I'm gonna use a similar thing that count and sort uses, in which you build up a counting array, and from that you can sort the array. But I'm gonna use I'm gonna create a function called find count array. So it's gonna take in a list, guys, and it's gonna return we're gonna accept the parameter, which is gonna be the count array length, and we're gonna return our count array, guys. Our find count array function is going to take in the minimum value of the list and the maximum value of the list. And from that minimum and maximum value, guys, we're gonna say int pointer count array equals to collect. This way we don't have to call memset because if we use the malloc to allocate memory, guys, then we would have to initialize everything to 0, or else we would have some random garbage values inside of our array that we allocated. So we use calloc instead of malloc. So we're gonna subtract the maximum value within our list minus the minimum value in our list, add 1 to that, and we're gonna pass in the size of an integer since our array is just an array of integers. And we're gonna iterate through our list now, guys. So for size ti is equal to 0, I is less than length of the list. So list.length, we're gonna say count array index list.array index I. So for each element in the list, guys, we're gonna use its element as an index to the count array, but we're gonna subtract the minimum value so that it remains in that range, guys. This way we don't need to allocate a whole lot of memory, even if our list has like, let's say our list has like a range of numbers from 1000 to 2000. We don't need to allocate an array of 2000 elements. Instead, we could just allocate an array of 1000 elements. So this solves the problem, guys. Now I'm gonna create a function to find the minimum and the maximum value inside of our list. So it's gonna take in our list and it's gonna return an int pointer, guys, and we're gonna return a min-max. We're gonna make this min-max variable a static one. Now I'm gonna let it be an array, guys. So it's gonna be like a little map. We're gonna say have two variables, one called min, and we're gonna set that equal to list.array index 0, which will be the first item in the array, and min equals to list.array index 1, index 0 as well. And we're gonna iterate through the array, guys. So list.length I++. We're gonna say if list.array, we can start at index 1 instead of setting I equal to 0. Since we already initialized the minimum and the maximum value to point to the first index inside of the array, right? Or the first element. So we're gonna say if list.array at index position I is less than the minimum value, then we're gonna set min equals to list.array index I. And we're gonna say if list.array index I is greater than the maximum value, then max is gonna be equal to list.array index I. And then we're gonna initialize our map, guys. So we're gonna say min underscore max index 0 is gonna be min underscore max index 1 equals to max. And then now guys, we're gonna create an array called, we're gonna create a function called find similarity score. Find similarity score. It's gonna take in our left list, and it's gonna take in our right list. We're gonna say int similarity score, set that to 0. We're gonna return the similarity score at the end of the function. Now guys, at the start, we're gonna return a pointer or a map to the minimum and maximum value in the right list. So we're gonna call find min underscore find min max on the right list, and the text on the right list, and then after that guys, we're gonna initialize two variables. So min is gonna be equal to min max at index 0, and max is gonna be equal to min max at index position 1. Now guys, we're gonna get our count array. So we're gonna say int count array equals to find count array, which is gonna be the right list guys. So what this function is gonna do, it's gonna count the number of times each element occurs within our list. And then guys, we're gonna return the length of that list. So we're gonna say count array length size t count array length. You set that to 0 guys. And count array length guys is gonna be equal to max value plus 1 guys. So after we have done that guys, we have got the count of each element inside the right list. Now we're gonna need to find the similarity score. So we're gonna iterate through the left list. So left for size ti equals to 0, I is less than the left list dot length, and meanwhile we're iterating through that guys, we're gonna say if, since we have like the minimum and maximum value guys, and we clamp the values to remain in that range of values. So for example, if we have numbers from 2000 to 3000 in our list, then it would actually be 1000 elements present in our list. So each time we're iterating through our list, we need to ensure that it exists within our counting array. So we're gonna say if left list dot array index I is greater than our minimum value or our left list dot array index I is greater, wait, hold on, if it is greater than our maximum value, guys, then that means we're out of the range of the element. So we're just gonna continue, meaning we're gonna skip that iteration of our loop. And if the item is in the range, guys, then we're just gonna say, of our count array, guys, then we're just gonna say, we're just gonna say left list dot array index I multiplied by count array index left list dot array index I minus the minimum value, guys, since we have subtracted the maximum value from the minimum value to let it remain in that range. And then we're gonna say similarity score plus equal to the current element multiplied by the count of the number, which is gonna be the number of times it exists in our right array. So let's try to compile this. So we made a mistake, guys. Warning, passing argument 2. Okay, so line 34, that is hold on, guys. So we pass in the right list. Oh, I see the issue, guys. So I forgot to pass in the minimum and the maximum value before we start calling that function. So, okay, guys, so now that we have done that, we can call our find similarity score function to see if it's working properly. So we have already initialized that, so we can just say similarity score equals to find similarity score left list right list. Then we can say printf the similarity score is similarity score. And let's compile it and see what we get, guys. So we have got 80, and that's far from what we should get. So what is the issue, guys? Because we're iterating through our left list appropriately. Oh, I think I know what the issue is, guys. Alright, if we look at this list, we can see that 9 is the maximum value, but the issue is, guys, we need to ensure that the value that we're incrementing the similarity score by is actually present inside of the right list. Since we are just letting the count array be within a specific range. So here is my idea, guys. So what I'm gonna do is iterate through or is less than the right list is less than the left list dot length, right? We're gonna check to see if it exists within our right list. So we're gonna say for size c, j equal to 0, j is less than the right list dot length, and we're gonna say wait, give me a second, guys. Alright, I'm back, guys. So what we're gonna do is say if left list dot array index I is equal to right list dot array index j, then we're gonna say similarity score plus equal right list plus equal left list dot array index I multiplied by the count array at index left list dot array index I minus the minimum value, guys. Now this code could be optimized a bit, guys, by using a hash map or hash set, but for now, wait, it still doesn't work, guys. What is wrong? Oh, I know what to do, guys. Hold on. Let me do like a simple test, guys. So I'm gonna open up my Python interpreter. So let's say we're iterating through the left list right here, guys. So we say 3 would exist 3 times. Then we say, oh, I see, guys. I see my issue. So I can't just say equal. Whenever I find it in the list, I just break. This way, yeah, and there we solved it, guys. So we can say our similarity score is 31. Now that we have solved that, guys, we can actually solve the puzzle. So let's see how many lines is in that. There are 1000 lines. So I'm gonna open up the puzzle.py index.txt, and let's run the code, guys. Alright, let's see if we got this correct. And we got it correct, guys. So thank you guys for watching, and I'll see you tomorrow for Advent of Code Day 2.